Good morning. The next step we have to derive the global stiffness matrix. Okay. So the step 6 is the assembly the element equation to obtain the global or total equation. By using the individual element equation can be obtained in the fifth step or added together by using of method of superposition. So how many elements you have to derive? For example, I consider two element means you have to add them the two elements. Okay. That is a superposition. The direct stiffness method. The final assembly or global equation which is a in form of F is equal to K into U. So here F is stands for global force vector and K is called as global stiffness matrix and U is called as a global displacement vector. So the global means is called as if I added together the all the element that is called as a global. If you are solving the individual element of the force or stiffness matrix or for displacement vector, that is called as a local matrix vectors. Okay. Yes. So the next method is yes. So once we have to apply the boundary conditions. For example, so the form the global stiffness matrix is a singular matrix because it is a determination is equal to 0. For example, in order to remove the singularity problem, the certain boundary conditions can be applied. So for example, if step number 8 we can solve it. So for solving the unknown displacement, if you consider as the one particular element has a fixed, okay, so if you have fixed element means that is a particular displacement value is 0. So you have to eliminate the respective rows and columns. Okay, but for example, I have to fix in the row number 1. Okay, if you are fixing the row number 1, the respective displacement value is 0. So if you consider U1 as a 0, so the U1 is which stands for you have to eliminate the corresponding rows and columns. That is stands for row, first row and first column. So the rest of the numbers you have to solve and derive the, you have to find out the unknown displacement. For example, I consider the third also if I'm fixed means if the U3 also 0. So when U3 is 0 means you have to eliminate that element also. For example, if I'm eliminating the third rows and third column. Okay. So if I'm solving these kinds of method, I have to find out the unknown displacement. So easy for solving the after applying the boundary condition. This is the more essential method to solving the FEA problems. Okay. These equations can be solved and unknown displacement you can or calculated by using of elimination Gauss elimination method or Gauss serial method. Okay. Yes. So the next one is the step 9 is the computations of the element strain and stress. So the formation of the solution of the displacement vector is called as a U. The stress strain value can be calculated. For example, E is equal to du by dx. So U stands for displacement field variable along the x-axis. E stands for strain. And also the stress strain relationship is given by sigma is equal to E into E. So sigma stands for stress and E stands for modulus of elasticity or Young's modulus. The final steps is we go for the interrupt the result. Okay, so the interrupt the result once we have to analyzing the all the steps like first step you are saying discretization of the solutions and the material assignment and this stiffness matrix of the individual element force vectors of the each node and displacement after applying the boundary condition once formation of the global stiffness matrix, so global force vector, global displacement vector, after eliminating the respective number of fixed supports, okay, so you got the unknown displacement of the respective nodes, okay. So these are the methods to carry out in the, whenever you are to analyzing the any types of problems, like a one dimensional problem or two dimensional problem or three dimensional problem, whenever you have to analyze these type of methods, is can be more useful for your solving the numerical problems. Okay, and also the same methodology we have to solving for the ANSYS working problem. Okay, the first step primarily we have to assign the step and you have to draw the material assessment. You have to choose the different what are types I have to method I have to choose like a steady state condition, temperature based problem, thermal energy, and also frequency model. So there are n number of types of method you have to have there. So you have to choose that method. After that, you have to assign the material. Then you have to move for the boundary conditions, apply for the each node. You got the correct solution for the exact answers. So the next step is called as a modeling and simulation. So how the FEA can be using for the modeling simulation is a more essential method to solving the different types of functional groups. We have to discussing later. Thank you.
Good morning. In this lecture series, we see about what is the meaning of variational method. So basically, the variation method is coming under Rayleigh-Ritz method. It is a basic phenomena tool can be using for the approximation of the finite element analysis methods, and also is a more effective tool to using the any other complex shapes. So like one is like a simply supported beam or cantilever beam, like etc. So based upon the minimize and maximize the function objectives to specify the constraints for the numerical approximation of an ordinary or partial differential equations. So this equations is put into the equivalent weight restricted integral form, then it can be approximate solution over the entire domain is assumed to be a linear combination of this type. So for example, the u of x is equal to summation of I is equal to n, 1 is equal to n, the ci pi I of x. The u of x is represented as an approximate solution in terms of approximate choose function that is called as a pi I. The undetermined the coefficient of is called as a ci. The creation of the approximation solutions or trial function of u of x is involving the creating a functions of pi of pi that is to satisfy the boundary conditions that contains the arbitrary adjustable constant ci. These coefficients are determined such that the integral equation equivalent to the original equation is satisfied. So the variation method is like a basic form of tool we have to apply. For example, if you are calculating total potential energy, can be written as the functional in a form of different integrals that has the integrate involving a single independent variable like x, a function of u of x. And the possible to derivative of the u of x is written as the integration of x1, x2, the function of x, u of x, u dash of x into dx. And the variation methods having a wide range of the by using approximation method is like a differential approximation method is of Rayleigh-Ritz method or Galerkin or least square method, a different form each other in a choice the integral form. The weight functions and the approximation functions. The essence of the approach is finding the function in form of the total potential energy of the system and to the invoke the stationary of the potential subject to specify the constraint to ensure the equilibrium. The variation method for suffer from the disadvantage that is the approximate function for the problems with arbitrary domains or difficult to construct. So for taking the Rayleigh-Ritz method is one of the example of variation methods. So if the variation form of the problem is exit, we have to function for the problems and approximate solution for the independent variable can be made up of by the creating solution function that minimize the functions. The selection of solution functions involves assuming the functions that are satisfy the boundary condition and also the contain the arbitrary constant that can be adjustable. So the Rayleigh-Ritz method is assume the trial function of the by using of this formation of u of x is equal to summation of I is equal to 1 into n, the ci pi I of x. The substitution into the main function that is the x of x1 to x2, the function x summation of I is equal to 1 to n ci pi I of x, comma, the summation of I equal to 1 n ci pi I dash of x. So it is a dash is called as the function can be differentiating one time and the given function is can be replaced as here second term. That is a whole term we have to integrate it with a specific interval time of that is x1 in the displacement of x1 and x2. The function now they involve their n arbitrarily constant like a ci which are determined by the finding the extreme functions we have to return as each constant. The resultant of the u of x is providing the approximation solutions. So the principle of minimum potential energy, we can solve the total potential energy and also we have to calculate the minimum potential total potential energy. For example, if I'm calculating the total potential energy, the summation of U plus V. So what is the U is called as a strain potential energy that is written as EA by 2 integration of x epsilon square into dx. The force of potential energy V is equal to minus FU. This is the basic of this is yes. The true configuration of the deformation, elastic quantity yielding minimum value of total potential. This is the basic of the development of the approximation technique for the equilibrium elastic problem. And the main principle of the minimum potential energy and strong the formulations are exactly equivalent statement of the same problem. The exact solution of that is satisfy the strong form that render the potential energy of the system is a minimum. So why use the principle of minimum potential energy is a short answer that the much less the demanding than the strong formulations. The long answer is they require only the first derivative to be finite and incorporate the force boundary conditions automatically. The assumed displacement, which is a function, that is you are need to choose the need to satisfy the only one displacement function. Thank you.